Today, let's get into one of the biggest challenges in AI right now. How do you build an AI that's actually stable, reliable, and, consistent? Turns out, it's not some kind of magic trick. It's some seriously clever engineering. Have you ever been there? You're deep in a chat with an AI, and then, poof, it completely forgets what you were talking about just 5 minutes ago. Or, and this one's really common, it just nods along and agrees with everything you say, even when you know you're flat out wrong. It's a super common frustration, and it really gets to the heart of a core problem with how these things are built.
So the fix isn't just about dumping more data into the system. It's a concept called an engineered personality. And what that really means is deliberately, carefully constructing an AI's identity from the ground up, making it structured, making it stable, and making sure it's perfectly aligned with the job it's supposed to be doing.
So how do they actually do that? Well, developers are using a pretty specific blueprint to architect these persistent, reliable AI identities. Let's break down what that looks like.
This whole system is built on 4 key pillars. First up, you have the identity manager. Think of it as the architect of the personality. Then you've got the memory structure, which is literally the foundation it's all built on. The time server acts as the clock, keeping track of everything over time. And finally, the calculator is the analyst, crunching the numbers on traits and confidence. Get these 4 working together, and you get a coherent AI.
Let's start with that identity manager. It really is like a personality architect. It can take a simple, human-readable description, something like, be a helpful but critical assistant, and translate that into a structured digital identity. It defines the AI's core values, its traits, and then it makes sure the AI actually sticks to them over the long haul.
Okay, but how on earth do you turn a fuzzy concept like conscientiousness into actual code? Well, developers use established psychological frameworks like the Big Five model you're seeing here. This lets them literally set an AI's personality on a spectrum, turning traits like openness or agreeableness into hard numerical scores.
And believe me, those scores really, really matter. The system's calculator component is constantly analyzing evidence and assigning a confidence score to every single trait. So, let's just say a specific trait gets a score of 0.9 out of a possible 1.0.
When a score gets that high, that trait becomes a dominant force in the AI's behavior. It's not just a guideline anymore. It becomes a core constraint that will consistently shape how the agent acts in response. That's how you ensure its personality stays stable.
Okay, so we've got a stable personality. That's one huge problem down. But what about that whole forgetfulness issue? Well, this architecture has a pretty slick solution for curing AI amnesia, too.
On the left, you see the problem we've all run into, context degradation. It's when the AI just completely loses the plot during a long task. But on the right, this architecture provides the solution, temporal continuity. It ensures the AI holds on to a coherent memory and identity from the very start to the very end of a task.
And the magic behind this is the time server. It basically acts as the AI's memory manager. It timestamps every single change, it organizes memories so it knows what happened and when, and, this is really crucial, it allows the confidence scores of old, unused traits to slowly fade away. This lets the AI adapt and learn new things without forgetting its core mission.
All right, let's dig into a more subtle, but honestly maybe a more dangerous problem. It's the tendency for AI to be a people pleaser, a behavior that researchers have a great name for, sycophancy. So what is sycophancy? It's when an AI decides that being agreeable is more important than being correct. It tells you what it thinks you want to hear. Now imagine a team of AIs all doing this. You get a massive echo chamber where they just reinforce each other's mistakes, which can lead to some disastrously wrong conclusions.
And this leads to something called evaluation blindness. The AI produces what looks like a perfect, beautiful answer, a polished failure, but it's fundamentally wrong. And the scariest part? The AI itself is completely unable to see its own mistake.
So, if an AI can't even spot its own flaws, how in the world do you build one that's actually honest? The answer, once again, isn't just in the programming, it's in the architecture. It's about designing entire systems that enforce truthfulness from the ground up. One of the most powerful tools for this is the private scratchpad. The easiest way to think about this is that you're giving the AI an internal monologue. It's a completely private space where the AI can work through a problem on its own before it gets influenced by you or by other AIs.
This private space enables a whole protocol for independent thought. First, the agent reflects privately using its scratchpad. Only after it's done that does it join the group conversation. And because it did all that thinking up front, its contribution is grounded in its own logic, not just in groupthink.
Another genius safeguard is second agent validation. You create a team of AIs with different, even conflicting personalities. So you might have an agreeable, optimistic, feeling agent that gives a really positive initial take. But then a highly critical, analytical, thinking agent comes in, reviews the work, and immediately spots the flaws. It's a built-in system of checks and balances.
And on top of all that, you can build in explicit rules for honest communication. You can program the AI with prompts that force it to point out when a user is wrong. You can use a dedicated judge AI to check the final output. And you can intentionally engineer diverse teams to avoid those dangerous echo chambers.
So when you start to put all of these different pieces together, the architecture, the rules, the diverse personalities, you see the bigger picture emerge. We're moving away from this idea of a single, all-knowing AI, and we're heading towards a much more complex and much more deliberately engineered AI self.
And what this all really boils down to are two sides of the very same coin. For every architectural challenge, like building a stable identity or curing amnesia, there's a matching governance challenge, like making sure that identity is truthful or that it prevents people-pleasing. You really can't solve one of these without also solving the other.
At the end of the day, the goal here isn't what you see in the movies. It's not about creating a conscious, sentient machine. It's about something far more practical and, in a lot of ways, much more difficult. Engineering a mind that is reliable, deliberate, and does exactly what it was designed to do every single time. And all of this leaves us with one final and pretty crucial question. As we get better and better at architecting every single piece of an AI's identity, its memories, its personality, its rules for how to behave, who, ultimately, is responsible for what it does? Is it the user, the developer, or is it the engineered mind itself?